Hello everyone. So recently I've been to this bounty on superteam and I did solve it. Okay. And was the celebration moment. I just you got it for of that. So let's talk about how did I do it and what was it. So it is MPL Bubblegum and Rust NIF for Elixir. So if you're not familiar what is MPL Bubblegum, it is just a library ecosystem, whatever you can call, to create compressed NFTs. And compressed NFT is a, a long topic to talk about, but just the thing is, somehow we are using just the Solana network, just the Solana blockchain to store a signature of file or some kind of data so that we can later on match and say that, okay, this image is actually a NFT which belongs to some person or whatever you can think of. So the problem was that they were giving a offering, okay, of bounty for implementing native implemented function. This is a cool thing to know or just for sake. So uh, in simpler words, okay, it's like combining a C or maybe some kind of compiled code with Elixir. And if you are not familiar with Elixir, either is just a language which is built on top of Erlang, which is yet another language, and that language is quite weird. Okay, Elixir is weird too for some sense. If you are not familiar with what is going on up here, you would be just thinking what you are doing in your life. So what I had to do was there is a library, this one, MPL Bubblegum. I had to map couple of this. If you are familiar with Solana, then you might know there is something called as instruction, and those instructions are combined and or maybe just formed to make a transaction, and that transaction can be executed. Are you familiar? If not, you can just have a Google. Why not? So, what I want to is, what I was to do is to create some kind of uh, library, and to see in action, I'm just show you it in action. Okay, let me just give you a look at how it looks, and then I will show you the library, and then I might go into a little bit of detail how did I do it. So you see, up here we got this transaction signature, and this this particular library, which is actually the test which is being executed, is doing it with Elixir. I will show you. I will show you for the moment just to see the transaction up here. Let and paste. Uh, it can paste or not. Why it is in there? Did I copy something wrong? Yeah, I did copy something wrong. That happens. Simple as that. Okay. So overall, what's up in here is there is a transaction which is creates an account, and then slide is a Merkle tree. A Merkle tree is a transaction, like it is something which is used in compressed NFT, and that was I was trying to switch. The code for it, the code for it is here. And if you are not familiar with Elixir, again, it will be a hard time for you to understand what exactly it is. But still, you can just read the name, and figure out what is happening. So This is a test case. Create an account and configure the Merkle tree. Up here, I did just generate whatever I did design here. For example, I imported my key and then I uh, made a public key of Merkle tree program. Okay, see, this is the Merkle tree program and there is the Merkle tree. This is just an account where the Merkle tree would be written. Okay. Then we connect to the client and so on. We created two instructions. Isn't it fully? Doesn't it look like how we used to do it in Web3.js? Let me give a context. Can I get a program? Can you give me an example? No. Here I can show. Maybe just see this one. It's kind of like that. You just take the make whatever addresses you want. Up here, he connected the client before, but yeah, see, there is a client being connected. There are some addresses being made. There is this block hash, latest block hash, which I've also took. You can just see in this part, latest block hash, and then at the end you form a transaction and can then confirm. Okay, oh, sorry, sign it up here, but in my case it happens. In this line you just provide the signer who will be not yeah this argument. It just tells what who are signing it. New sign transaction with pair. You can just uh, figure out. Okay, so he had just broken up part and two, but idea is one because that's how it was implemented in Rust, and then it didn't make sense to break them apart. Okay, cool. So you saw the code, you saw the thing in action, you saw the account being generated, and for sake of showing the repository, it's still there. It's still there. I'll probably be uploading this video after the boundary is closed, so like it can't copy it. Anyways, this is just attempt. You can just see the same things which I told you. Import the keys, connect to RPC, and instruction. You have to create block action, things like that. Cool. Okay. So first question, how did I do it? First question is did I do it? So for me, if you are just looking for some kind of similar thing, okay, maybe you are looking for some bounty or something like that. First of all, read the description and most probably you will land up with something to start. If not, go and Google. Okay, so first thing which I saw was wrestler. Okay, uh, not this wrestler. NIF. This wrestler, what we are talking about, and it is just a library framework. Framework. It is just a framework which can help you actually translate a Rust function into Elixir one, just the way I showed you. Okay, you can for me to get started, I had to go through this, which didn't make sense to me at first, and then I thought of maybe I should read a PDF. Does it have recents? Yeah, I read this PDF. Not everything. I I went through this first step building and control flow, data abstraction, and I left from here. I didn't read chapter 5. I didn't read. after this I just skip because these things are cool actually, but these things isn't required for me. So first listen, read what is required for you. Don't go for everything. Not always, but yeah. When you are doing something, you want to do something, just go for what is required and finish it off. You will learn over time because you cannot just go up and read everything, isn't it? So this book is cool. You should learn. You should have a read or read around. Maybe if you are actually interested in Elixir or Erlang or something like that. It is particularly for Elixir with a little bit of description of how Erlang has come to the existence. Mm. In mid 90s, there is this company Ericsson. Okay, Swedish telecom giant. They wanted a system to do their telephone operation. Okay, and the cool part of Elixir is, or Erlang I should say. The cool part of Erlang is that it is a whole stack, like whole stack of things. What you require, you can just do. Yeah, I was just willing to show you this table, just for a little bit of interest. It is interesting that way I'm showing. So, uh, Erlang itself, it can work as a HTTP server. For example, you use Nginx and it can replace the Nginx. It can replace your request processing stuff. It can replace your long running routines. For example, something you write in Go Rust or something like that. It can even replace the caching, like server side, server wide state stuff. It can persistent data like MongoDB. You can understand that it can replace everything. And I don't know why they make it in such a way that this language makes sense for a telecom service. Okay, so this language is like this framework or runtime, whatever you can, I should say, what runtime is so cool that if you have a running system, if you have already made some software, made some grips or something like that, you can update it while it is running. Have you ever seen that? Isn't it cool, weird, whatever you can say? So suppose you have a service going on, and you want to update it. Even if you think, just look at other things. Maybe you want to update MongoDB. You will just, for your MongoDB stuff, you will have to restart it, like shut it off, restart it. For those times, we are willing to have distributed stuff so that it doesn't happen on my machine all at once, and the whole database doesn't go off by just one update. Like things like that, we are just looking for. While in Erlang, it's like I have update, I'm just pulling it, I'm just doing it, and it is being done. That's the beauty. That's the beauty of the language. And I'm something weird too. So Erlang is such a language which can do the easy things hard and hard things easy. Somewhere I read that quote from this book only. So this is a Erlang code. Yeah, it doesn't look something interesting because it's hard to understand this code. Even Elixir code is a little readable, but a few of the things are so weird that it's hard to understand internally what is going on at first glance. And one of the very weird things is that every variable in Erlang or Elixir is immutable. And that's, I don't know why do they need it? Maybe that update stuff, live update, hot update, whatever it is. So whenever you create a variable, it will be assigned. Whenever you want to update a variable, a new variable will be created and the new data will be assigned and the new variable data, like you can think of. Every time you update something, new assignment is done instead of something being replaced. Good. So this means that whenever you write a Elixir function, the function is very sure what it is doing. If it fails, you still have the data. You don't lose it. Cool. So, I will just take you to a little tour of what is in this project. So, maybe you want to, yeah, for everything, for creating this project in Solana, Rust one, you have a command, Rust mix, like there's a package manager mix. You can see mix, Rustler. Yeah, new with this, I just created a package, or you need to add the Rustler to your this, and then you have to do the mix or mix install, mix get actually, not mix install, mix get you have to do, then you can do the mix build, like things. Cool. Mix that. Something I forgot that. Anyways, because I did it once, I didn't have to do it. Don't have to do it much, lot of time, and I don't know where I'll be using this language again. So first of all, we broke our project into multiple sections, multiple sections for some reason, multiple files. Okay, so we can have things clear. I will like to show you probably line code maybe. Yeah, let me. It's a little weird. Let me show you the simplest public. Okay, this one is a simple one. So if you are willing to add something to this repository, you can just go up and see. Otherwise, you will have to tinker a little if you are willing to put some other new. If you want a very detailed video on that, just please text or drop a message or whatever you can think. Cool. So in Solana, from the Solana SDK, which is a Rust library, you can see a Rust code. We have public key. It is a public key which will be containing the public key. Cool. And that public key, for that I've created a wrapper. Whenever you have something for that's what I follow. Whenever I have a data type which I don't want to convert to Elixir, it doesn't make sense to convert to Elixir, because if I do that, there will be so much of conversion back and forth. That doesn't make sense to me. Okay. Then I made a wrapper for it. I made a wrapper function so I can just use it whenever I need. No. The thing is, there is something called as resource. Okay, resource. And that resource trait need to be implemented on a type. And if you implement that resource trait, then only you can use something called as resource arc. And if you use a resource arc, you can straightforward return a Rust data type as a reference to Elixir. Do you get me? Yeah. So if you have in simpler words, if you have a data type, you want to put it into a resource arc and give it to Elixir as a variable. Uh, maybe just let me show you where it is happening in tests. Okay, you need it. Here I did create a public key here. Okay, cool. You see, Merkle tree. I missed P up here. Anyways, so Merkle T program ID, just think that's program ID. Okay. So this variable is a reference and is made using this one only. You can see this is the no, this is the actual function from string which I have called public from string, and there is a result being going on for the, in Rust we have okay and error, and that okay become colon okay colon atom something. Atom is just a name, simple as that. It just it's like you are defining a symbol, and that symbol doesn't have a string, any kind of data, but just random ID or something like that. It's fine. That's why we use it. Simple. So you want to, yeah. So you want to implement this resource wrapper, and since you cannot implement a trait from other crate and then structure from other crate on a structure from other crate, like either a trait should belong to your crate or the structure should belong to your crate. If they both are not from your crate, you cannot implement anything on anything. Cool. That's why I created a wrapper so I can implement the source and I can pass it out. Cool. And this wrapper is cool too. And with that, I just return it whenever I take it. Like if I am taking string or something like that, then cool. I don't have to bother anything, tinker my head too much around it. But whenever I am taking some kind of data, which is a rush time, I will be surrounding it with resource arc again. For example, this key pair. This is yet another structure which like wrapper of key pair from Solana SDK, which I'm using, and that's it. That's it. You can see, and wherever you create a function with this wrestlers colon NIF, okay, this macro, you will define that function in here. And you know what? Uh, If you define the function in here, you will notice one thing. Though I created multiple modules, though I put everything in here and there, it doesn't matter. Overall, the whole math is that everything will be staying in one file. Yeah, I didn't get a good way to group them yet. Even the example from the library, I wasn't able to figure out how to do that. But if there is some data, some structure, correct, you can create modules. Okay, and every like see in Elixir, one module can be seen as a structure too. Yeah, that's true. You can see a module as a structure. For that, you have to define a def struct stuff here. And yeah, it's not Rust or any C stuff that you can create multiple def struct inside one module. The module is a struct. This situation, not every time. Create when? Well, you don't have to worry too much about that. Anyways, so this is how it works. And you can just put up things from that, and I will highly recommend you to do it. And that's cool. That's cool. That's all about it. And I will show you the most complicated one probably up here. This one is the most complicated one because these are the instructions from the MPL. Okay, I would like to show this one. Okay, there is something called as NIF struct. If you just look into the library, you will just get about it. So that's what I've used here. Might be looking a little weird, but yeah. With all this, I have put my librarian's idea, what I showed you. And that's it. I just made this library. I would love, I would love to see some kind of contribution in this. And if you like my work, you can just tell me that, okay, I want this instruction in this. I will do it for you. Anyways, thank you. That's all. That's all. I did submit it. You can see edit button because it's already submitted and sooner it will be over. So, okay. Thank you.